Okay, we are on matrices. So under matrices, we'll look at the definition, the types, addition and subtraction, multiplication, determinant of 2 by 2, just 2 by 2 and 3 by 3 matrices, minus, cofactors, adjoints of a matrix, inverse, and also learn how you apply it in solving simultaneous equation. So we start with the first one, that's the definition. Definition: a matrix is a rectangular array or arrangement of numbers enclosed in a curved bracket. Curved bracket, very important. So we are saying that if you have something like this, let's call it matrix. Maybe the numbers 1, 2, 3, maybe 4, 5, 6. So anytime you have numbers enclosed in a curved bracket, it is called a matrix. Or maybe this type of bracket, the two are the same. Maybe 4, 5, 6, 3. So this is also a matrix, but this is not a matrix. Maybe if you have 4, 5, 3, 7. So this is not a matrix. These two are matrices. So that's it. Whenever you see numbers arranged in that form, that's a matrix. So the next thing, we normally name a matrix by row and column. So the horizontal arrangement, this is the row. So coming here, 1, 2, 3 is the row. So this is J. Maybe if you have 4, 5, 6, 7, 8, 9. Maybe let's call the matrix P. These ones are the row, the horizontal, while this the vertical are the column. So as you can see, this matrix has 2 rows and 3 columns. 1, 2, 3 columns. 1, 2, 2 rows. So, and in naming a matrix, we name row by column. So we normally name a matrix by row and column. So this is row by column. So this is, look at this, this is 2 by 3. So that's this multiplication means by 2 by 3 matrix, meaning 2 rows and 3 columns. Why this one is 2 rows and also 3 columns. So this is 2 by 3. Why here is 2 by 2. Why is, okay, this is not a matrix. So that's it. So we name a matrix by row followed by column. So the next thing, we look at types of matrix. So the first one is singular, diagonal matrix, identity matrix, triangular matrix, symmetric. So let's start with the first one, square matrix. A square matrix is a matrix that has equal number of rows and columns. So a matrix with equal number of rows and columns is called a square matrix. It has a special diagonal that runs from the top left to the bottom right corner, called the leading, or you call it the main diagonal, or you call it the principal diagonal. So also we have a special number assigned to it. It's called the determinant. So I'm saying that, see an example of a square matrix. If you have maybe matrix M, maybe if you have 2, 3, 4, 5. So this is a square matrix because it has the same number of row and columns. So that must be the same. They must be the same. So this is a square matrix. But this is not a square matrix. If you have like 4, 5, 6, 8, 9, 10. So this is a square matrix. Why not a square matrix? Because this one has 2 rows. This is 2 by 3. So whatever that is here must be there to make it a square matrix. So coming to what we call the leading or the main or the principal diagonal. Any diagonal that runs from this. So this diagonal from the top left to the down right. So that's it. So this is called the principal, or if you don't call it the principal, you call it or the main. If you don't call it main, you call it the leading. So any of the thing diagonal. So if you don't call it the principal, you call it the main or the leading diagonal. So for every square matrix has a leading diagonal. So the next one is called the diagonal matrix. The matrix that the elements are 0 except the main diagonal. So if you have a matrix, it must be a square matrix, remember, for it to have a main diagonal. So any matrix that the elements are all 0 except the one in the principal diagonal or main diagonal. So if you have like maybe 4, 5, 6, others are zeros. So do you see it? All these elements, they are not 0 except the ones in the what? Principal diagonal. Or if you don't write it this way, some textbook will just write just the element in the principal diagonal. So if you don't see it this way, this is a diagonal matrix, or you see it this way, so that's it. So all the elements except the ones in the principal diagonal are 0. So this is called a diagonal matrix. The other one is called the identity matrix. Identity matrix that all the elements, a diagonal matrix that all the elements of the main diagonal are all 1. So it's not a special type of diagonal matrix. Instead of being any arbitrary number, maybe it must be 1 all through. So do you see the difference? The elements here are all 1, not just any number. Or maybe if you write it down, because it's a diagonal matrix, so that's it. So an identity matrix is also a diagonal matrix, but a special one that all the elements are 1. So the next one is the triangular matrix. A triangular matrix is just a matrix that the elements above or below the principal diagonal are all 0. We now have what we call upper or lower triangular matrix. It is called lower if the elements above are all 0, and it's called upper if the elements below are 0. So example, if you have matrix A, maybe 2 0 0, 4 5 0, and maybe 6 2 3. So what do you notice? The elements, this is the principal diagonal, the elements above are zeros. So this is called a lower triangular matrix. But if you notice that the elements below, maybe if you have 2 3 5, maybe 6 7 here, 8 0 0 0. So this is called an upper triangular matrix because the element below the principal diagonal is 0. So this is called the upper triangular matrix. So remember, it's possible both of them could be 0 up and down like this. So we can still call identity matrix a triangular matrix. So this is also a triangular matrix. Because it obeys the definition. So that's it. This is also so an identity and a diagonal matrix are all triangular matrices. So the next one is symmetric matrix. A matrix is symmetric if the matrix and its transpose are the same. Though we've not done transpose of a matrix, but I will just explain it so that to give an example on this type. So if you have a matrix such that if you transpose it, they will give the same results. So this means this is just the transpose of A of matrix A. So whenever you see a matrix raised to a power T, capital letter T, means transpose of the matrix. And what is the transpose? Transpose is just a matrix that you get by interchanging the rows. The rows and columns. So, and to interchange this, you need to be careful. You interchange first row for first column and maybe second row for second column. So if you have a matrix, let me give an example. Maybe if this matrix A, maybe 2, 3, 4, 5. Then the transpose is, this is the first row. It will now become our first column. So interchange. The first row becomes the first column, while the second row becomes the second column. So example of such matrix now. This is just to explain transpose. So see, example of such matrix. If you have like matrix P, maybe if you have 2, 3, 5. So you have 2, 3 and 5 as the elements of the principal diagonal. Maybe if you have like 8, -1, and maybe 7. This is our principal diagonal. It acts as a mirror. So this is our line of mirror. So once you reflect this, this is 8. This should be 8. This is -1. This is -1. Why this is 7? So any matrix of this form, once you transpose it, it will also result to the original matrix. You try it, you can see, try it. First row becomes first row, 2, 8, -1, 2, 8, -1, 8, 3, 7, 8, 3, 7, -1, 7, 5, -1, 7, 5. So do you get? So the easiest way to get this, once you write the element of the principal diagonal, whatever that is here becomes a reflection of that. So you reflect 8, 8, -1, -1, 7, 7. So this is what we call a symmetric matrix. We now have what we call skew symmetric. A skew symmetric is the matrix that is equal to the negative of its transpose. So if you have a matrix A such that is -8 raised to power T, or maybe if you have 8T equal to -A. You have a matrix A, see how we generate it. The elements of the principal diagonal must be zeros all through. Yes, that's the first thing you have to know. The elements of the principal diagonal must be 0 all through, and it acts as a line of mirror again. So whatever that is here, maybe if you have 4, 5, -3, becomes the negative reflection of what is here. So if here is 4, here is -4. If here is 5, here is -5. If here is -3, here is 3. So that's the only condition. The elements of the principal diagonal must be 0. They are all zeros. And this becomes the negative reflection. That's it. Try to transpose now. See, if you transpose the 0 for this, after you multiply by negative, you get the original. So that's it. That's what we call a skew symmetric matrix. So the next one, a singular matrix. A singular matrix is a matrix that the determinant is 0. Though we've not done determinant, but we still do it. So you normally, if you have a matrix A, we denote the determinant as bar A. So if the determinant is 0, or maybe det A, so whenever you see det A, it means determinant of A is 0. So that's it. While the opposite, which is the non-singular matrix, so when the determinant is not 0, so if the determinant is not equal to 0, the other one we have column matrix. So any matrix with only one column but as many rows as possible is called a column matrix. So it's very simple. We have a matrix A. So this is a column matrix because there is only one column. Maybe if you have 8, 9, 10, 11. So this one has 3 rows, but this one has what? 4 rows, but only one column. So this is just a column matrix. The opposite is row matrix. So if a matrix has only one row and as many columns as possible, so if you have P equal to maybe 2, 3, 8, 9. This is a row matrix, or maybe if you have Q equal to 4, 8, 9, 10, 11. So this one has 4 columns, why this one has 5 columns, but only one row. So let's now get to the real thing, addition, subtraction. So that's it.